Okay, in this lesson we're going to continue our work with exponents. And if you take a look at this fraction on the board, it says 2 to the second power divided by 2 to the fourth power. And there's lots of different ways you can look at this. I know one way, we could write it all out. 2 to the second power means 2 times 2. And in our denominator, 2 to the fourth power means 2 times 2 times 2 times 2. On top, 2 to the second power turns into 4. And on the bottom, we have 4 and another 4. 4 times 4 is 16. We can simplify this. Divide both the numerator and the denominator by 4, and we end up with 1/4. So that original problem, 2 to the second power over 2 to the fourth power, simplifies all the way down to 1/4. Another way to look at the exact same problem, 2 2's on the top, 4 2's on the bottom. And we could simplify first. We could say that a 2 from the numerator and a 2 from the denominator cancel and turn into 1's. Same thing with this group. And simplify from there. On top, 1 times 1 is 1. On the bottom, 2 times 1 is 2, times another 1 is 2, times another 2, 2 to the second power, which I know is 1/4. So again, we get 1/4. A third way to think of this problem is something we talked about earlier when we have a fraction like this. We said if the bases are the same, which they are here, we keep the base. So the base is 2. And then we subtract the exponents. On top we have a 2. On the bottom we have a 4. 2 minus 4 is -2. So 2 to the second power over 2 to the fourth power is also 2 to the -2 power. Now negative exponents, something brand new, something you haven't seen before. So somehow we got to be able to figure out how 2 to the -2 power turns into this, 1 over 2 to the +2 power, which turns into 1/4. One way to think of this, kind of a shortcut, a strategy, is to look at this 2 to the -2 power, which we have right here. And you could think of it this way. You could say the negative sign, if you stretch it out, it turns into a fraction bar. The other pieces, the base, goes to the bottom. And the exponent, which was a -2, turns into a +2, which also goes to the bottom. And we fill in the top, the numerator, with a 1. And then we simplify from there, 1/4, or 1/4. So the shortcut way says keep the base, subtract the exponents. If we get a negative exponent, like we did here, the negative sign stretches out into a fraction bar. The base and the exponent slide to the denominator on the bottom, and we fill in the numerator with a 1, and then we simplify from there. So let's practice a little bit. If we wonder why that works, think of it this way. 2 to the first power is 2. We learned previously that 2 to the 0 power is 1. So if we're looking for a pattern here, how do we get from 2 to 1? We divide by 2. So if we continue that pattern, dividing by 2, 1 divided by 2 is a half. And if you think about what we just talked about on the last slide, this negative exponent, the negative sign becomes a fraction bar. The base and the exponent slide to the bottom. We fill in with a 1 on the top. 1/2 to the first power is 1/2, or a half. So our pattern works. If we try the shortcut here, 2 to the -2, we stretch out the negative sign into a fraction bar. The base and the exponent go to the bottom. We fill in the numerator, the top, with a 1. That simplifies to 1/4. Let's see, would that fulfill our pattern here? If I had a half and I divided it by 2, half a pizza divided into 2 pieces, yeah, that's 1/4 of a pizza. Let's see if it works here. 2 to the -3, the negative sign stretches out into a fraction bar. The base and the exponent go to the bottom. The numerator is a 1. We simplify that. That's 1/2 times 2 times 2, which is 1/8. And again, that works. If I had 1/4 of a pizza and I divided it into 2 pieces, that would be 1/8 of a pizza. So let's look at these two examples. Simplify each expression. Simplify means find an answer if we can. It also means use only positive exponents. So 5 to the 6th power over 5 to the 8th power. The bases are the same. We keep the base of 5, subtract the exponent. 6 minus 8 is -2. Our shortcut says grab that negative sign, stretch it out into a fraction bar. The base and the exponent go to the bottom. Fill in the top with a 1. We have 1 over 5 to the second power is 5 times 5, which is 1 over 25. That's our answer. Variables are even easier than numbers today. The bases are the same. We keep the base of m. 2 minus 5 is negative 3. Remember, simplify in our directions. Get an answer if we can. Also means make sure you use only positive exponents. So m to the negative 3, remember the negative sign stretches out. Fill in the top with a 1. The base and the exponent go to the bottom. So 1 over m to the third power is our answer for that one. Your job is to try all 3 of these. Now's a good time to stop the video and then come back after you've tried all 3 and I'll go through the steps to solve them. Okay, in letter A here, using our shortcuts, the bases are the same, so we keep the base. The base is 4. Top exponent minus the bottom, 5 minus 7 is negative 2. Simplify means find an answer if you can. It also means only positive exponents are allowed. So this negative exponent, remember the negative sign stretches out into the fraction bar. The base and the exponent go to the bottom. We fill in the top with a 1. That means 1 over 4 times 4, which is 1/16. That's our answer. Same thing in letter B. The shortcut says keep the base. The base is A. 4 minus 6 is negative 2. The directions said simplify. Simplify means we only want positive exponents. So we're going to stretch it out. 1 over A to the second power. And that's our answer. Letter C, just a little tougher. Remember, when you have numbers and letters, you should break it into 2 separate problems. So I have 3/9 as one of my problems. I have y to the 8th power over y to the 12th power as my other problem. I know I can simplify 3/9 by dividing both pieces by 3. That turns into 1/3. Y to the 8th over y to the 12th. Following our shortcut, that's y to the negative 4. But simplify in our directions means no negative exponents allowed. So this turns into 1 over y to the 4th. Now we got to take our 2 answers and put them together. On top I have 1 times 1, which is 1. On the bottom I have 3y to the 4th. That's our answer. All right. Now in this one, the directions change a little bit. It says write this expression, x to the second power y to the third power, all over, or all divided by x to the third power y. And it says write your answer without a fraction bar, or no division symbol allowed. So a couple things here. First, you got to remember that all numbers, all variables have an exponent. Here's an exponent of 2, here's an exponent of 3, here's an exponent of 3. There is an exponent on this y. It's the invisible 1. So, since we have 2 separate pieces, we should treat this as 2 separate problems. A problem with x's and a problem with y's. The first part, x to the second over x to the third. Keep the base. Subtract the exponents. 2 minus 3 is negative 1. Now the directions say without a fraction bar, no division symbol. So x to the negative 1 has no fraction bar, no division symbol. This part is done. Now I jump to the y's. The bases are the same. I keep y. 3 minus 1 is 2. Directions said without a fraction bar. This does not have a fraction bar. I'm done. That's my answer. X to the negative first power times y to the second power, which we know can be written just by sliding those things next to each other also. Both ways are acceptable. Same directions on this one. Write the expression without a division symbol. So no fraction bars, no division symbols in your final answer. Pause the video, come back after you've tried all 3. Okay, hopefully you've had time to try all 3 of these. The first one, the bases are the same, so keep the base. Subtract the exponents. 3 minus 9 is negative 6. Directions say without a division symbol. So this is my answer. Some people might think, well, don't I have to stretch it out and do this? If you do that, you have now put in a fraction bar, which is a division symbol. So that is not your answer. This is your answer. It's important to read the directions. Letter B has 2 parts. It's got the m's and it's got the ends. So again, treat it as two separate problems and then bring your answers together at the end. Keep the base of m, subtract the exponents, get -3. Keep the base of n, subtract the exponents, I get -6. And the directions say no division symbol, no fraction bar. So this is my answer. You can write it like this. You can put a multiplication sign in between. Both ways are correct. When you get to letter C, don't forget that every variable, every number has an exponent. The invisible 1 exponent is right there on that x. So treat it as two separate problems. I've got x's, I've got y's. X's first. Keep the base, subtract the exponents. 1 minus 5 is -4. Y's are next. Keep the base of y, subtract the exponents. 5 minus 3 is 2. This is my answer. You can put a multiplication sign if you want. If you have questions, be sure to ask. Good luck.